Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yeah, hello everyone. A very good evening to everyone present here. So, how many people have already come? Can you please write your name in the chat box to mark your presence and so that we can begin? And also, kindly tell me in the chat box that I am properly audible and visible. Hello, Dilavar. Good evening, Dilavar. So, let me share my screen and we can very quickly start. Or should we wait a few minutes for other people to join as well? Yeah, my screen is also visible. Okay, so we have 9 people with me together. Let me give you a small introduction about what this is about for those who are joining for the very first time. This is a series about graph and tree for your interview preparations. And if you're preparing for your upcoming internships and placements, this series will be very, very helpful. This will be almost a 1 hour session in which I will be basically discussing concepts and questions related to graphs and trees, which are basically asked in from interview point of view. Okay, and today is the fifth session. We already have done fourth session in which we have covered quite a lot of topics. And today is basically a practice session in which we will be practicing two questions. I have handpicked two questions which are very frequently asked in interviews. Okay, and this series will go on for the remainder of the December and the first week of January, and we will be meeting every alternate day at 10 p.m. on YouTube. Let me introduce myself. My name is Gourav Kumar Shaw, and I am presently in my third year at IIT Kharagpur, and I'm also a mentor at Geeks4Geeks, and I also have a software engineering internship for the upcoming summers at CureFit. Okay, so let us start with the session. So, the students who are present here in the stream, can you please mention in which year of the college you are in right now and also your name of your college? And are you targeting are you targeting internships in the next year? Hello, Dilavar, are you there? And one more request, I would request the students who have joined with me to kindly stay with me till the end. It's not a huge session, it's just a 1 hour session, and we will be discussing two problems. And yeah, and this will, yeah. Are you all ready? Yeah, let us start then. Yeah. Before I start, let me just give you a recapitulate of what we have previously done. And we already had four sessions, and in those four sessions, we have discussed about concepts like to graph representations. After that, we have discussed about traversal algorithms like DFS and BFS. We also discussed about 0 1 BFS, multi-source BFS. We also discussed about connected components, how to find them using DFS and BFS both. Okay, and apart from that, yeah, and we also in the first session we also discussed about terminologies of the graph and trees. Okay, and with the various representations. So these five topics are already covered, and Kulkarni is saying that brother, I'm in second year and I'm in tier three college. Okay, no worries. You should work hard at whatever position you are in right now. Okay, let us start with the session then. And one more request I would like to have is that since Today we will be discussing two problems. Mostly they will be solved using DFS and BFS. So students who already know the concept of BFS and DFS very well and good, and who do not know the concept of BFS and DFS, kindly stay with me. I will just touch the topic a bit, but I will not be going into the depth. But you can revise it after the session, and you can continue with the series onwards. Okay. So let us start. The first problem that we are going to do here today is called replace O's with X's. I hope everyone can see the screen, right? So let's start with this problem. Yeah. So let us read the problem statement then and what is exactly it is trying to say. And so the problem statement says that we have been given a matrix MT of size n cross m, where every element is either 0 or x. Okay. And we have to replace all the zeros, all the O's with x that are surrounded by x. A O or a set of O is considered to be surrounded by x if there are x at location just below, above, and left and right to it. Okay. So what exactly is this question trying to say us? Okay. So let's look into that. I hope everyone have read this question. So the question is saying that we have to replace, okay, we have to replace all those O's which are basically surrounded by X in all the directions. Okay, we have to replace all those X and then we have to return. Okay, so basically as you can see in the question, we see that these O's are basically uh, surrounded by X's in all four directions, and therefore we are basically converting them into X and then returning the matrix. Okay. So let us see certain concepts and observations that we can make related to this. Yeah. So basically, what exactly is this trying to say us? So, so in the question, it is saying that we have to replace all the O's with the X's, which are surrounded by X in all the four directions. So, can you tell me that let's say I have a matrix which looks something like this. There is a O, there is a X, there is X, there is another X, there is another X, there is O, O, O. These are X's. Can you tell me that all these the O's are basically surrounded by X's? Are all these O's surrounded by X's? Are they? Yes or no? Can anyone tell? Yeah. So welcome, Sumit. I remember you were in my last session as well. So did you revise the concepts which were taught? And I remember you said that you were in your first year, right? Okay, so Sumit is saying no. Yes, no is the correct answer. So why exactly this is so? Let us see. So basically, as you can see that as you can see that these zeros are connected, are basically surrounded by x's in the right side and also in the left side as well. Okay, but in the top side we do not have any x's. Okay, because that is the end of the grid, so we cannot see that these o's are basically surrounded by x's. Okay, so let us look into another. Hmm. So let us look into another example. Okay, so let me just rub this out, and yeah. So basically, let us say that if this is a zero, and this is zero, this is another zero, this is another zero, and it is surrounded by all the x's. Okay, yeah. So if I'm giving you this matrix, and if I'm asking you that whether all are surrounded by x's or not, then what will be your answer? Your answer will be yes, because as you can see that these zeros are surrounded by x's on the top side, x's on the bottom, x's on the left, as well as x's on the right. So basically these are surrounded by all the directions, and the question is asking me that you have to replace these o's with x's. the O's which are surrounded by all the X's in all four directions, you have to replace all of them. So finally, after replacement, this matrix will look that all the boxes of this matrix contain basically X, because there are no O's remaining after we eliminate this. Okay, so this is the concept. Now, the question is that we have to. So, what exactly are the observations that we are making? Can anyone tell me? Sumit, Dilavar, can you tell me what exactly is the observation that we should make here, and how are we going to proceed to solve this problem? Which algorithm we will use? We have learned a variety of algorithms till now, and what we will use to solve these. Okay, can you tell? Yeah. So, give 2 minutes to type. Okay, okay, Sumit, take your time. Okay, sorry about that. I was not audible. Sorry, my mic was off and I did not notice it. Okay, so yeah, so I was asking Sumit that how will you basically convert those zeros which are not in the boundaries but also connected to the boundaries? Okay, because those are also invalid, right? You are saying so the zeros that are not touching boundaries will be converted to X. Okay, but what about the zeros which are not touching the boundary but are connected indirectly to the boundary zeros? Okay, because what is happening is that we in the question is not asking for any single O zeros or O's. The question is asking that we can take into account a block of O's as well, just like I showed. Because in this graph, as you can see, that all these zeros are invalid zeros. Okay, we cannot convert them to X's because they are connected to the boundary zero. Okay, okay, so we are not taking any particular zero. Yeah. So Sumit is saying we will be do BFS on the zeros in boundary. BFS on the zeros in boundary. Okay. Sumit is saying BFS on. So what type of BFS is this? Zeros in the boundary. Dilavar, yes, you were saying you could not understand the question. So let me repeat it once again for you. So in the question is saying that you have been given a matrix which contains a bunch of O's and X's. And the question is asking that you have to convert all those O's to X's which are surrounded by X's in all directions. Multi-source BFS. Okay, Sumit, can we do this by applying DFS instead of multi-source BFS? So can you write a approach that requires a DFS instead of BFS? Since I will be discussing two problems, the second problem involves the concept of BFS, in fact, multi-source BFS. For this problem, I will be using the concept of DFS. Okay, we will do DFS on all the zeros in the boundaries and mark all the zeros found as visited. Exactly, Sumit. We will exactly do that. Okay. So since Sumit has said this concept, so let's look into it. So Sumit is saying that what we will do, we will do a DFS traversal on all the zeros which are at the boundary, and we will mark them whatever nodes that are coming in our traversal. We will mark them as visited. Okay. So yes, that exactly will be the algorithm for us. The algorithm says that from boundary we will do a traversal and all the zeros and mark them visited, and then which are connected in all the four directions. Okay, and again traverse and find the not visited zero and do replace them basically. Okay, so this is what exactly is the concept. So let me just have a let me show you a graph then. Okay, so it will look something like this. Let's say there is a zero here, there is another zero here, there are x's 0, x's 0, 0 x x 0 0 0 x 0 0. Let this be x. Let this be x, let this be x. Okay, so let us say that this is our matrix. Okay, this is our matrix. So Sumit is saying that what we will do, we will traverse the boundary first. So let us say we are traversing the boundary. So once we are traversing the boundary, we see that this zero is a boundary zero. This is also a boundary zero. This is also a boundary zero. This is also a boundary zero. Okay, this is also boundary zero. Now Sumit is saying that what we will do, we will basically do a DFS traversal on the boundary zeros. So let's say I do a DFS start. Initially, I take this as the starting point and do a DFS. So what else this node will try to mark? It will not able to try to mark any node because there are no zeros connected to the this. Okay. So in DFS, we will make sure that we will mark only those cells which are zero. Okay, which are zero. Okay, and connected to the boundary and connected to the boundary connected to the boundary. Okay, so this is what we will try to do. Got it? Now, yeah. So we see that. Let's see. We come to this zero. Okay. So once we are this zero, we can see that this zero will try to make this as visited. This will automatically mark visited. This will try to make this as visited. It will again go to the next depth. It will mark this as visited. It will return back, do a recursive traversal, mark this as visited. This has visited. Again, it will mark this as visited. Okay. Now, as you can see that all these zeros are already marked visited. Okay. Now, if these zeros are already marked visited, it means that we can no longer consider them in our final traversal, final inversion. Okay. Now we see that there are no further zeros which are unvisited in our boundary. Okay, then we will stop. After we so now what happens is that we have already eliminated those zeros which we do not want to invert. Now again we will traverse our matrix. Again we will traverse our matrix and check for the zeros which are not visited and are still zero. Okay, the not visited cell and are still zero, and we see that there are only these two zeros which are not visited and are still zeros. Now we will convert these zeros into x's. So these zeros will be converted to x's. These o's will be converted to x's, and the zeros which have already marked visited, we will not touch those zeros. We will remain, let it be as it is. Okay, so this is the concept. Okay, so let us implement the DFS function then. So what exactly is the DFS? DFS is a depth first search. So what happens in DFS is that we traverse recursively down any particular path and we try to mark it visited. So basically what we will do, we will give this DFS function two parameters, a row and a column. Why row and a column? Because this is a matrix, the graph is in the form of a matrix. And at the same time, the first thing that we will do, we will mark it visited. Okay, this row and this column, we will mark it visited. Now next we will check that we will move in all the four directions. Okay, as per the rules of DFS, we'll move in all the four direction and we'll see if they are not visited and they are equal to an O. If they are not visited and they are equal to an O, then again we will call the DFS function for the same purpose, right? And after this entire DFS gets over, we will basically mark all those O's as visited which are connected to the boundary O. Okay. Now, this is a very famous concept of movement array Basically, we use this concept whenever we want to traverse in various directions in a matrix type graph. Okay, in a matrix type graph, right? So this is a movement array. So what happens is that we run a loop from 0 to 4, and we try to update our rows and column according to these values. Okay, and these values, once we update, so basically this will travel once in the right, once in left, once in top, and once in bottom. So therefore we are covering all the possible directions. Okay, so this is how this basically happens. So let us look into the coding part of it and how we are going to implement. Okay, so the code. So there are various steps of the code that we will write. So let's, yeah. Oh, sorry, I forgot to change the slide. So this was the implementation of the BFS and also the travel matrix. Okay, so let us look into the coding part. Okay, so how exactly are we going to write the code part? Okay, yeah. So the code part. The code part will basically have, the first part is the traversal of boundary. Okay, traversal of boundary using for loop. Okay, first we will do traversal of boundary using for loop. Okay, now then what we will do? We will call DFS, and we will also keep a visited array. Okay, we will keep a visited array as well. This array will basically mark as we are visiting. Okay, we will call DFS for all the boundary zeros if they are not visited. Not visited. Okay, we will call DFS array, and we will also implement a DFS function as well. After we have implemented a DFS function, we will again run a for loop to our given matrix, and then on our given visited matrix. Okay, not the original matrix, because it doesn't make sense, because we have already seen. Now we will see if they are they are not visited and they are equal to 0 in the original matrix. Then what we will do? We will create a new answer matrix also. Okay, so basically the question is saying that we can replace also, then that is also good. So we will replace by x, and finally we will be done with this. Okay, so let us see the code part. Okay, so I'm sharing the screen for the coding part. Okay, so this is a coding ID, the GFG ID, and in this I will be writing the code. So let us see that how we are going to do that. Okay. So basically, I have already written a big, yeah. So let me explain it to you. So how these are. So this is basically the movement array which I have just explained, that this array will be used for movement. Now this is a visited array. Now since it is a matrix of size n into m, so I've created a visited array, a vector of size n into m. So this is how we are declare it. After that, what we do, we traverse the first row and the last row. And how we are going to do that? We are going to do that from 0 to m. The first row and the last row. Okay. So the first row and the last row we will visit. Now we will see whether the visited of 0 comma j, 0 comma j, this is basically visiting the, it is not visited and the matrix value is equal to O. We will call it DFS. This is for the first row and this is for the last row. Okay, the difference between the first row and the last row is that the initial value is 0, the ith value is 0 for first row, and ith value is n minus 1 for the last row. And the jth value will remain same, which will traverse from 0 to m. So that is why this for loop is traversing the first row and the last row, and we are similarly calling it the DFS function. And in the DFS, we are supplying basically the coordinates as well. Okay, 0 comma j will be our coordinate in case of it is in the first row, and in case it is in the last row, n minus 1 comma j will be the coordinate. Okay, I hope everyone is following with me. Okay, so in case if you have any doubts, you can write in the chat box and I will take that up. Okay, so let us proceed. Yeah. So again, we will run a for loop. Now this time it is for the first column and the last column. Okay, because this is also a boundary. Now we will see, this is basically checking the first column, and this if statement is checking the last column. And similarly, we are again doing a DFS. If it is in the first column, we are sending the coordinates I comma 0. If it is in the last column, we are sending the coordinate I comma m minus 1. Okay. At the same time, we are sending the other parameter also, the visited array, the matrix, the movement array del row and del col. Okay. So now what we will do, let us see the visited array. Let us see implement the DFS function. Okay. So how exactly are we going to do that? We have already discussed the DFS for call. So what exactly a DFS function does is that it initially marks the coordinate in which we are basically supplying the DFS function. We initially mark them as visited. Okay. So this is our DFS function. It is accepting well, a lot of parameters. The first parameter it is accepting is, just a minute, guys. Yeah. So the first, I guess my mic was switched off. So let me just repeat it once again. Yeah. So this is the DFS function. In this DFS function, we are initially passing the row and the column. Okay, the coordinates of the row and the column. Now after that, we are basically marking the rows and the column with 1. Okay, because we have to mark it visited. This is as per the rules of DFS. Now we are going in all the 4 direction. We are checking the top, bottom, left, and right. Okay. The first is the we are now calculating the new row and the new column. Okay. Now we have to check that whether that new row and new column is valid or not, because it may happen that we are going outside our matrix grid, so we don't want that. In that case, we will get us a garbage value. After that, we are checking the validity. If it is a valid coordinate, then we are checking whether it is a visited or not visited. If it is a valid coordinate and it is not visited, the third condition we have to check whether it is an O or not. If it is an O, so if these 3 conditions are met, that it is a valid coordinate, it is not visited, and the third condition is that it is a O, then what we will do? We will do a DFS for that O, for that coordinate. Okay. We will again call coordinate. So basically, after this DFS function will keep on running recursively, we will mark all the O's. So after this DFS function keep on calling, we will mark all the rows, all the O's which are connected to the boundary O's. Okay, so those will be marked as visited in our visited array, because that is what we want. Okay, so after what that we will do, we will check for all the unvisited O and then convert it into X. We will run a nested loop and we will see if it is not visited in our visited array, and it is a O in our matrix, then we will convert that to O, because that is the question was asking. So basically, the question was asking that we have to convert all those O's to the X's which are surrounded by X in all directions. So after we eliminate those O's which are not surrounded by X's in all direction, we will only the only remaining O's are the valid O's, and we will convert them by running this two nested loop. So let us submit this problem and check whether it is correct or not. And we are finally returning the matrix as well. So, any doubts? We have 12 people with me right now, and so the students who are joining new, can you please mention your name in the chat box so to increase engagement and interaction? Yeah. So, Sumit, Dilavar, are you there with me? So, as you can see that all the test cases have passed, and therefore this problem is correct. So, let us move to the next problem then. So, meanwhile, does anyone have any doubts? You can ask me. The next problem will be the problem of rotten oranges. This is an extremely famous problem. So, okay, Sumit, do you have any doubt, or you have understood everything? Then we should proceed. Yeah. One more thing I'll request you all that what you can do is that you can invite your friends at your colleges and other people onto this streaming, and so that we can all learn together. And secondly, I would request you all to kindly like the streaming as well as subscribe to the GFG practice channel. And we have a plans that we will be bringing a lot of content on this practice channel. And if you all follow this practice channel in itself, will be completely enough for your preparation. Okay, that all the it is planned in such a way that we will be covering all the topics related to data structures and algorithms. Okay, so let's let's start then. Yeah. Okay, so the next problem that we are going to discuss is the problem of rotten oranges. Okay, now this is a little bit tough question. So, but we will see how exactly we will do it. Okay, the question is saying that we have been given a grid of dimension n into m. Okay, where each cell in grid can have either value 0, 1, or 2, which has the following meaning. So 0 can be either an empty cell. So 0 means that it is an empty cell. 1 means that it has a fresh orange. 2 means that that particular cell has a rotten orange. The question is saying that we have to determine what is the minimum time required to rot all the oranges. So basically, how we will rot all the oranges? A rotten orange at an index I comma j will can rot other fresh orange at index I minus 1 j, I plus 1 j, I j minus 1, I j plus 1. That is up, down, left, and right unit in 1 unit time. Okay. So, and we have to tell that what is the minimum time it will take. Okay. So that there are two things here. The first is that we have to traverse in all the four direction and the second is that we have to find the minimum time. Okay. So what are the first of all things that you are getting in your mind? Can you tell me? Any ideas? Yeah. And also one more thing it is mentioned that if it is not able to rot any particular orange which is not able to rot, then we will return -1. Okay. So let us see how we will do it. Yeah. So the question is already clear to all of you, I guess. Dilawar, did you understand the question? Yeah. So let us again start then. The question is the rotten oranges. 0 means it is empty, and 1 means that we have got a fresh orange, and 2 means that we have a rotten orange. Okay. Now it is saying that in 1 unit, what we will do, we will a rotten orange will rotten all its neighboring oranges in the top, bottom, left, and right directions, and we have to find the minimum time that is required to rot all oranges. Okay. So So this is in fact the question and how we'll do it. Let's see. Let's do a dry run first of all. Okay, because doing that will help us understand. So let us say that this is our given matrix. Okay. So let us say that this is our given matrix. Okay. And so how exactly are we going to proceed? So we see that this is a rotten orange, this is a rotten orange, and this is a rotten orange. Okay. So in the first second, what will happen? Let's say this particular rotten orange will rot this orange. Okay. In the first second. In the first second, this particular rotten orange will can also rot this orange. In the first second, this particular rotten orange will rot this orange as well as this orange. Okay. So in the first second only, in the first second only, all the oranges got rotten. All the oranges got rotten. Okay, so our answer will be equal to 1. Okay, one more thing, guys, that is most important here. We have to find the minimum time. Okay, and how exactly we are finding minimum time? Minimum time can only be found if we are considering that all the initially present rotten oranges are rotting the fresh oranges at the same time, simultaneously. We can say simultaneously. Okay, so if there are any rotten oranges, it will try to rot its neighboring oranges simultaneously. If there are multiple rotten oranges, it will do that simultaneously. Okay, so this is the concept. So how exactly are we going to solve? Hello, Santosh. So any ideas about how to solve this type of question, you can write in the chat box. And I would like to mention this that during the month of August, I was going through my campus internship drive, and this question, this rotten oranges question, was asked to me in Amazon interview. Okay, this exact same question I was asked to code in Amazon interview. So as you can see that these questions are very important from interview point of view. Okay, so the concept, anyone? Sumit, Santosh, Dilavar. We have 12 people with me right now. Anyone can write the concept. So, can anyone write the concept very briefly in the chat box? We will find all the 2's in the matrix and NQ them. Okay. We will find all the 2's in the matrix and NQ them. Okay. So basically, by using dynamic approach, can you explain please what exactly is dynamic approach? So let's go by what Sumita said. So what we will do, we will find all the rotten oranges. Okay, we will find the coordinates. We will find the coordinates of all the rotten oranges. Okay, in the initial problem we saw that now we will do something like level order traversal of tree. Okay, and what exactly is the level order traversal? Do you know? It is nothing but BFS. And since we are having multiple starting points, we will apply the concept of multi-source BFS. Okay, now few important observations that I would like to have here. Why BFS and why not DFS? Do you know that if we apply the concept of DFS, we will get a wrong answer? Because in the question it is mentioned that we have to do a minimum time. And in the question it is also mentioned that all the basically rotten oranges are simultaneously rotting the other oranges as well. So if you are applying DFS, so what does a depth first search does? It basically goes in the depth of the arrays and keeps on going into the depth of the array. Okay. Yeah. So in case, do you know what will happen? Basically, in that case, what will happen? We'll not be able to find the minimum time. Okay. So let's come to this part only, and yeah. So yeah, let us look into another example and see why this will fail. Okay. So I'm doing writing an example here, and I'm telling why DFS will fail. So let us say there is two here. There is one. There is another one. There is one. There is one. There is one. There is two. Okay. Now let's say remaining are zeros. Okay. So basically, this is a rotten orange. So let us say I am doing a DFS. Okay. So DFS, let's say the starting point of DFS is this node. Okay. So in DFS, what it does, it tries to keep on going into its depth. Okay. So this will go to this depth. This will go to this depth, and we will calculate the time. So this will go to this depth. This will go to this depth. This will go to this depth. So the DFS will tell me that it took a node 5 seconds to basically rot all these oranges. It took 5 seconds, but basically, what will happen if we try to run a DFS simultaneously on the other node? It won't be like possible, something like that. The only way it can be possible is that if any algorithm it is doing the concept of level order traversal. Okay, why level order? Because the idea is that in any given second, a rotten orange can only rot those oranges which are present at a level one greater than its current level. Any given second, a rotten orange can rot only those oranges which are present which are present at a level one greater than the current level. Okay, so this is how it will proceed. So how exactly are we going to do it? Let's see. Yeah. So how will the code structure look like? Our algorithm, how will it look like? So basically, the first thing that we will do is uh, the first thing that we will do, we'll run a nested loop. Okay, we will run a nested loop, and then we will count. We will basically put a queue. In that queue, we will put all the rotten oranges. Okay, so this queue will contain all the rotten oranges. Suppose these are the coordinates of the rotten oranges. After that, what we will do? Okay, so after that, what we will do? We will take one rotten orange out, and then we will try to basically run a loop into my entire queue. Okay, we will run a loop into my entire queue. Why entire queue? See, so all these are basically present at, let's say, level number 0. Okay, the initial the initial coordinates that we have put into our queue are the coordinates that are present at level number 0. Now, basically what we will do, since these are present at level number 0, this will rot only those apples or oranges which are present at level number 1. Okay, so how to do that? We will run a for loop. Okay, for loop to the entire size of our queue. Whatever elements are present in our queue, will run a for loop for that those. And what it will do, it will try to go to its adjacent neighbor. If it is a fresh orange, if it is a fresh orange, because all these oranges will take 1 second to rot its neighboring orange, any one of the neighboring orange. So okay, so we will move in all the four directions. Okay, we will move in all the four directions, look for fresh orange. If it is a fresh orange, we will rot them, and once we are rotting that fresh orange, what we will do, we will put them again into our queue. Now this will be level 1. Okay, so initially we are enqueuing all the coordinates which are at level 0. Then we are rotting all those fresh oranges which are present at level 1. After rotting them, we are putting them in the queue. So once basically all the level 0 coordinates are processed into our queue, we will only have those coordinates which are at level 1. And from the transition from level 0 to level 1, 1 second have passed. So basically, it took 1 second to rot those oranges which represented an immediate neighbor to the initial oranges. Now the same process will again repeat. Okay, it will keep on repeating until my queue becomes empty. When my queue will become empty, it means that there are no oranges to rot any further. Okay, so it means that all the oranges have either been rot. Okay, so after that, what we will do? We will just print the. So what the question is asking? The question is basically asking us that we have to print the time it will take. Yeah, so we will keep a counter variable and we will run a count plus plus. So basically we will keep a timer variable. So the number of level traversal we are doing, we will increment the time variable and then tell that yeah, so this is the time required. But there is one edge case that we need to be consider. Okay, can anyone tell me what exactly is the edge case that we should consider? Anyone? Yeah, yeah, that case is basically, okay, what exactly is that case? That case is that it may happen, okay, that there is a orange, there is a fresh orange which is not surrounded by any rotten orange. Okay, so basically there is a fresh orange which is not surrounded by any rotten orange. It means that, let's say this is a fresh orange and all the oranges which are surrounded by it are 0. Okay, means in the four directions. Okay, not diagonally. Okay, diagonally it can have, but in the four directions all the oranges are all the basically are empty cells. Okay, so in that case what will happen, even after doing a multi-source BFS, this orange will remain fresh. Okay, in that case we have to output -1 because it is asking in the question. Okay, the question says either find the minimum time to rot all the oranges. If it remains that it is possible that we are not able to rot any particular given orange, in that case we will output -1. Okay, so how to implement this edge case? So there are multiple ways we can basically do, but let me tell you one thing. Initially what we do, initially when we were running a nested loop, right? Okay, to basically enqueue our those coordinates which are uh, which are basically having a rotten oranges. So what we will do basically, we will keep a count. We will do a count plus plus of all the fresh oranges. Okay, when we were traversing across our given matrix. So this will have a count fresh. Count fresh will contain all the count of fresh oranges. After that, what we will do, when we were doing the BFS part, we were rotting oranges. Okay. Now, while in the process of rotting oranges, we will keep another variable count and do a plus plus to keep a count of all the oranges that we have rot by our BFS algorithm. Okay. So basically, oranges rotten by BFS algorithm. After that, we will check. After the BFS gets over, we will check whether this count fresh is equal to this count or not. If it is not equal, in that case, what we will do, we will basically return. If they are not, if they are equal, then we can return the time. Okay, whatever time we have accumulated till now. And if it is not equal, it means that there is a orange which basically is still remaining fresh. Okay, so in that case, we will return -1. Okay, I hope everyone understood this concept. Any doubts here? So that we can move to the coding part. Hello Sumit. Hello Dilavar. Hello Santosh. Any doubts? Any doubts? Okay, Santosh, thank you for understanding. Okay, no. So let's move to the coding part. So let me share the screen. Yeah. So this is the IDE GFG practice problem, and let us see how to do that. So as I have mentioned, the first part of the code was to basically enqueue all our rotten oranges. Okay. So let us see how to do that. Okay, so the first part was to enqueue my coordinates of the rotten oranges. So initially we declare a variable nnm which contains the coordinates or the dimensions of our given grid. Now we declare a data structure of type q. Q contains a pair. Now that pair contains two values. The first one is a pair and the second one is a integer. Now what exactly this q will contain, let us see. This q will store, first of all, the q will store a row and column. So this is a row and column, and the second value the q will store is the time. Okay, so basically, let's say if you're starting a multi-source BFS from any given point, in 1 second it will go to its next level. So it will store the time. So if at any point of time while we're running the BFS, the second number will tell us that this much amount of time has passed since the beginning of the traversal. So this value will store the time. So we need to store two values, the coordinates and the time. So this pair is storing the coordinates and this value is storing a time. And since there are two values, we are taking a q of type pair of int. Okay. So this is our data structure that will help us store our values. We also need a visited array, okay, because how we are going to know whether it is whether we are visiting it or not. Okay. In the same time, as I've just mentioned, we also need a variable count fresh, okay, to just handle the edge case. Now we will run a nested loop and we will traverse across our given grid. Now we will check whether the grid of ij is a rotten orange or not. If it is a rotten orange, we will push it into the grid. Okay, so we will enqueue it into the grid and see the time we are mentioning is 0 because initially the time is 0. Once it will start rotting, we will just increment the time to time plus 1. So initially we are making it 0. And since we are making it 0, we will marking that visited array as 2 because it is a rotten orange. So we are marking it as 2. Okay, got it? So we are marking it as 2. After that, what will happen is that we are again another else. We are coming to the else part. So what exactly is the else part? If it is a not a orange or not a rotten orange. So in that case, there are two possibilities. It can either be an empty or it can either be a fresh. But what we will do, we will keep the visitor array as 0 because we are just enqueuing the rotten oranges. And since we are enqueuing the rotten oranges, it becomes visited because we will be running BFS on the enqueued coordinates. Okay. After that, what we will do? We are also doing a count fresh as well. So initially, as I mentioned, in order to handle the edge case, we need to keep a count of all the fresh oranges as well. So if the grid value is equal to 1, it means the orange is fresh. And we will do a count fresh. Okay, count fresh plus plus. So this is how it will proceed. After that, it's time to do the BFS. Okay, so we have enqueued it properly in our queue. Now let's do a BFS. Now for BFS, we need few things. The first is a variable time. The next is a movement arrow and a variable count. Okay, so let's keep that. So initially, this is a time variable. This will calculate the time it is taking for the entire process to happen. These two rows are basically for the movement array because we need to traverse in all the four directions. This will keep a count of all the oranges that are being wrought by the BFS algorithm. Okay. Now finally, we will write a BFS algorithm, which basically is a while loop. And let us see that. So this is our BFS algorithm. Okay. So the BFS algorithm has, we will run a while loop as long as the queue is not empty. The first thing that we have to do is the root under consideration or the coordinate under consideration. A coordinate has three parameters. The first is row, the second is column, and third is time. So we will take the row by q of front dot first and the first because the first is a pair. So we will do first of first and first of second. Okay, and we will also get the column in this way. After that, we will find the time. The second parameter was giving me the time. So q dot front dot second will be the time. Now what will I do? I will take a maximum of these two time. Why exactly am I taking the maximum? So tm is equal to max of whatever value it has been present here. Okay, because if it is a maximum, it means that this is the time that it should be there. Okay. So now after that q of pop, we will pop that element because we no longer need that element. We are already processing that element. Now we will make room for other elements to come. Now we will go to its four direction. And exactly there are four neighbors, top, down, left and right. And that is the reason we have created a movement array. That movement array, with the help of movement array, will create new coordinates which are at the top, at the bottom, at the right and at the left. After we create the movement array, we have to check its validity, that whether it is a valid cell or not. If it is a valid cell, then it's okay. Now we will check whether it is visited or not. If it is a valid cell and also it is not visited, in that case what we will do, we will check whether it is a fresh orange or not. Okay, so three conditions need to be checked here. The first condition is that it is a valid cell. The next condition is it should not be visited. Okay, and the third condition is that it should be uh, a fresh orange. In that case, what we will do, we'll push in our into enqueue it in our queue data structure. And how we will enqueue? We will enqueue the new row and the new column, and we'll also enqueue the time plus one. Okay, so because the timer has increased by one, so we will enqueue time plus one. And finally, what we will do, we'll mark it as visited. And row and end column will mark it as visited as 2. Okay. And then finally, we will do a count plus plus as well. Because since we are routing that orange by our BFS algorithm, we need to keep a count as well. So that we can check for the edge case. Okay. This was a bit long problem. I hope everyone is with me. Now finally, the work is very easy now. We have to just check whether count of fresh is equal to count of fresh or not. Count the number of oranges that we basically wrought with our BFS algorithm is is not equal to the count fresh. If it is not equal, we will return -1. Okay. And if it is equal, in that case, we will return the time we have accumulated till now, which will be our minimum value. Okay. So let us submit this problem and see whether this code is correct or not. Yeah, as you can see, all the test cases are passed, and so therefore this question is correct. So any doubts till here? Hello Sumit, did you all understood it? Hello Santosh, did you understood it? Hello Dilavar, are you there? So kindly have a response of those who are already here, so that we can wrap up our session. We have already moved to the end of the session. Okay, thank you Sumit for understanding. And if you have any questions related to little bit understood, okay Santosh, what will happen is that after the live stream, this will stay recorded and you can watch the recording to properly understand it. I would recommend you to learn more about BFS, multi-source BFS, and about how to solve this problem and practice a bit. Okay, so that you can be prepared for the next session as well. Next session we will be talking about bipartite graph, and after that we will be doing a few topological sorting as well and a few problems as well. Then we will move on to trees. Okay, what you do, I am a third year student at IIT Kharagpur. Okay, so I'm a student just like you all. Okay, so this is the first the link of this Google Jamboard slide is basically in the description of the of this video. You can refer to that later. So those who joined the session at the late, let me introduce myself again. My name is Gaurav Kumar Shaw, and this series, let me tell you more about this series. This graph and tree series are basically for interview preparation. In this series, I will be covering all the important concepts and questions required for interview, and we are meeting every alternate day 10 p.m. live at YouTube. Okay, and we have already covered topics like the representation of graph, traversal techniques like BFS and DFS, 01 BFS, multi-source BFS, connected components, how to find them using DFS, BFS, and today we saw about two important questions as well. Okay, so next we will be telling about bipartite graph, and we will be talking about few more problems. And apart from that, yeah, let's see what happens in the next session. Okay, you'll come to know. When will you come tomorrow? I'm not coming tomorrow. I will be coming day after tomorrow, every alternate day at 10 p.m. on YouTube live. Okay, Vinod, got it? Today was a practice session. We practiced two problems, two very important problems. The second problem which we did was basically asked to me personally in my Amazon interview just few months back in the month of August. Okay, so I hope, yeah, then that's we are finally wrapping up this session, and a very good night to all of you. So let's see you again in the next session. Bye Sumit, bye Vinod, bye Santosh, bye Dilavar if you're there. Thanks a lot for joining and listening to me. All the best.